Hello, today I will be covering some science. So the first thing we're going to go over is significant figures and the things you do with them. So these are the rules up here. Whole numbers are always significant. Leading zeros are never significant. Middle zeros are always significant. And trailing zeros are sometimes significant. This is the first rule. As you can tell, these are all whole numbers, and so all these count as a sig fig. Down here we have rule number 2. Leading zeros are never significant. So all these zeros in front of this whole number are not significant, so this leads us to have one sig fig. Middle zeros, which are any zeros trapped in between two whole numbers, are always sig figs. So in this number we have 4 sig figs. Now this is the trailing zeros, and this will sometimes come into play. If there's a decimal point at the end of the number, or anywhere in the number, the zeros are always significant. If there is no decimal point, the zero is not significant. So in this number we have 3 sig figs because there is a decimal point. In this number we do not have 3 because we only have 2 sig figs because there's not a decimal point. So now it's time to get into how to do a multiplication, addition, subtraction, division with sig figs. Hello, so this is adding and subtracting, multiplying, division with sig figs. So now when you're adding and subtracting, sig figs don't really matter. You use the lowest decimal point. So in this one right here, we have 200 plus 1.1, and that would be 201, because the lowest decimal point is 200, so it would be 201 and not 200.1. Now with multiplying and dividing sig figs, you do use the lowest sig fig. So since the lowest significant figure is 200, and that's 1, the number has to be 1. So there can be no point at the end of this. Now if we were to add a point at the end of 100, this would go from 200 or from 2000 to 2200, because the lowest significant figure would be 2. So now after this we're going to go on to doing some ratios and stuff. Okay, so now that you know how to do sig figs, you can move on to stoichiometry. Now stoichiometry is not the only thing you do that involves sig figs. Any math you do throughout chemistry, you need sig figs. And speaking of sig figs, this problem right here involves using sig figs. So before we can start solving problems, we must read the equation. So you need to look at these coefficients. These right here, they don't really matter unless you're looking for grams, and grams we're not looking for at all throughout these. But later we will do some problems that involve grams, and then these will matter. But right now these numbers do not matter. These letters do not matter. Elements or compounds, you know what, they're called anything that you want to call them. Okay, so then you read the problem. So you're looking for moles of O2 that would be formed with 1.65 moles of KClO3. So now you set up the equation by doing 1.65 moles of KClO3 over 1 times 2 or times 3 moles of O2 over 2 moles of KClO3. Now, you get these numbers from the coefficients up here, as I talked about before, which is why the coefficients are important. And so after you multiply the top numbers and then divide it by the bottom number, you will get 2.475. Now this number right here is what you're looking for to use sig figs, and since there's only 3, it will only turn out to be 3 sig figs. So you would round up the 5 to 4.8 or 0.48. So now onto problem 2. You're looking for how many moles of KClO3 are needed to make 3.5 moles of KCl. Now, what you start off with is setting up the equation like you did before, with what gives you over 1. Now you times it and you set up just like we did before. 2 moles of KCl equal 2 moles of KClO3 over 2 moles of KCl. Now you set this up like this because these numbers divide each other and these get cancelled out. And then these numbers cancel each other out. And so you get left with the numbers. So you have 3 moles times 2 moles divided by 2 moles. Now in theory you could just erase these two and just put them as 1 since it's a whole number. So it would be 3.5 times 1 divided by 1. And you will get the final answer, 3.50 moles of KClO3 are needed to make 3.5 KL or KCl. So now I'll give you about 10 seconds before I continue to solve this problem. You can pause the video, you can do anything you want, but start now. Okay, so this is what you should have gotten from the from the answer, which again, like up here, you're doing the same two numbers, so these cancel out and each of them become 1, and so 2.73 times 1 divided by 1 is still 2.73. So now we'll go on to doing some grams to moles. Hello, so now that we've done moles to moles, now it's time to go one step higher to go from grams to grams. Now you could just do grams to moles, which is just these two fractions right here. You would do this times this, or this divided by this, and that will give you the number of moles you will have of this. But since we're going from this number of grams, from this element's grams to this element's grams, we need to do a full fraction equation. Big fractions equations now. So, to start, we do the same thing as before. We look at the coefficients, then we look at the problem, which we have 3.76 grams of KClO3, and we're looking for the number of grams that will turn into O2s. So, we set up how we did before with what we're given over 1, and then we come down here to cancel out this. So we will cancel out these with this, and so you go to the periodic table of elements and you look for this. So you will look for potassium, chloride, and oxygen. Oxygen's 13, or not 13, 16. Chlorine is 35.45, and potassium is, I don't remember. Potassium is 39.1. Or well, when you round up, it's 39.1. So, after we cancel these out, we do over 1 mole of KClO3 over 1, or over this 1, because this is a number of grams, and 1 mole of potassium potassium chloride, I don't know how you would say that compound's name. Then you come back to what you did before with trying to figure out the difference. So 2 moles of KClO3 is equal to 3 moles of oxygen. And then you come down here, you cancel these out. So 1 mole of oxygen is equal to 16 grams of oxygen. And you multiply everything on top and divide it by everything on the bottom. So you would get 0.736 grams of oxygen. So this top number divide by this bottom number, which is 1.22 or 122.55 grams times 2, and divide it by the number you get from up top as well, and you get this. Then now we will be looking for this, which is the same thing. You do 30 grams of KCl over 1, and then you set up the same way. You find these compounds or these elements, and you find out the molar mass of it. So the molar mass is 74.55 grams over 1 mole, because that's how many moles are in it, which is why it's called the molar mass. Now, then you look for the coefficients. So it's again just only 2. So this entire fraction doesn't really even matter, to be honest. And then you come over here to grams. Or then you go down to 1 mole of this equals 122.55 grams of KClLO3. I think I said 2 L's. You know what I meant? And after you multiply everything on bottom and multiply everything on top, and then divide the top by the bottom, you get 49.3 grams of KClO3. Now remember, do not skip this step, because if you do, you could get confused, because you have to go from this mole to this mole. And now, like before, I want you to try to solve this bottom by yourself. Okay, so now that you've done this problem, it's time to go over it. So, the answer is 1.66 grams. Now remember, if you get something else, it's because you didn't go to the significant figure, which is the third significant figure. So, you take this number and multiply it across, and since these two are 2's, and you don't have to worry about them. So you just take this number, you multiply by this number, and then you take the number you get and divide by 122.55. Then you will get this number. Now, I hope this was helpful, and I hope you learned something from this. I'll be doing more of these, not just science. I'll be doing math, English, a little bit of everything, and if you guys want to know anything, I'll take my time and do research on that subject, and I'll try to teach it the best I can. Not going to say I'll be able to teach it like a professional school teacher, because I am a high school student, just trying to help people do better in high school, or learn what they want to know. So, if this was helpful, like the video and just show me that it helped you a little bit. Leave a comment saying that this helped me do my homework, or this helped me cheat on the test. If you cheat on the test with this, I'm not at fault. But if you do and you get an A, then I guess I helped you, and you're welcome. I'm not condoning cheating on tests, but I'm just saying. But if you would not enjoy this, you would think this is helpful, just leave a like and comment down if you want me to teach anything else, or if you just thought this was good, or what I could improve. Now, I know I'm not the best at this, 1, because I'm a high school student, 2, I'm using paint.net to do all the work. So, yeah, not the best program, but it does get the work done. So, I'll see you in the next gaming video, or if you just come here for the learning, then I'll see you in the next teaching video I do. And have a good day.